Hi, good afternoon everyone. I am Monica Emul and today I am presenting on topic on syntax directed translation SDT for backpatching. What is a syntax directed translation? Uh, Syntax directed translation is a method used in a compiler design that integrates syntax rules, means grammar, with semantic actions like code actions or instructions that define how each rule behaves. There are some key points of SDT. Grammar plus actions. SDT uses grammar rules like those in a BNF combined with semantic actions like generating code or setting values to guide how source code is translated. The purpose of SDT, it helps translate high level programming language code into intermediate code. So next is a backpatching. What is a backpatching? Backpatching is a compiler technique used when generating a intermediate code, especially when the destination of certain jump a statement not yet known. Means when generating a code for boolean expressions flow of control statement, we may not know the label or address that control must go to, and we can solve this problem by generating a series of branching statement with target of the gems temporarily left unspecified, means the go to statement from to leave a blank space. So we will see one example on backpatching. In first example is a less than b or c greater than d and e less than f. Firstly, we take with go to blank space. Then we decide where we jump to the go to and fill the address. So it is known as a backpatching. Backpatching means leave branches undefined and patch them later. Uh, in that example, a less than b is a true, so overall condition is a true because of or condition. If a less than b is a false, so we check a greater than b and e less than f. These two statements will true, then overall statement is true. if any if any of the one condition is a false, so overall condition will be false. First we write if a less than b go to statement is true, so we leave a blank space on to the go to statement. So we next write go to 102. Next is a if c greater than d, if this condition is true, so we remain leave us blank space on go to statement, and next we decide what is the address on this place. So overall same like this process further. And 106 is we can assume this a true block, and 107 we can assume this a false block. So next we will see the solution of this backtracking. Uh, if a if a less than b is true, so overall condition is true, which statement is executed. In this example we assume that 106 is a true block, so we can write here 106, and next is a 101, go to 102. If a less than b is a false, then we check c greater than d and e less than f. So where we write c greater than d, so c greater than d we write in a 102, so we can write here 102. And in next statement 102, if c greater than d is greater, so we check e less than f. So e less than f is right in a 104, so we can write here 104. And if c greater than d is a true and e less than f is a false, so overall condition false, so false statement is executed, so we can write go to 107. And if c greater than d true and e less than f is true. So these two statements are true statements. So execute the true statement. So we can write 106. So it is the process of backpatching. It is called as a backpatching process. So next we will see some functions used in a backpatching. First is a make list, second is merge, and third is a backpatch. In make list, we create a new list with only I and index into the array of instruction where I stored an index with array of instruction. And second is a merge x1 comma x2. It concatenates the list pointed by x1 and x2 and returns a pointer to the concatenated list. And third is a backpatch p and I. Insert I as the target label or address for each of the instruction on the list pointed to by p. So next is a backpatching for Boolean expression. Uh, in Boolean expression, as the Boolean expression used as same, we can use another operators like or, and, not, brackets. Relational operations are used in Boolean expression. So first example, first we can x produce x or x1 or m x2 and x1 and n m x2 and not x1 and in bracket x1 and id1 rel of id2. It is a true or a false. So m contains x clone, so it is nothing but a x clone is nothing but a nothing. So first is a x produce x1 or m x2. It create a two list of x. First is a x true list and second is a x false list, and it x true list and x false list it merge and is stored in x. If x false list, we can m dot instruction and address it make backpatch with address. And second is a x produce x and m x2. In or where true list and false list, that place in and operator. True list in take false list and where false list is take true list. Next is a x produce not x1. In that x1 is true, so x is false. So in that, and x where x is false and x1 is true, it is the opposite. So it is called as a x naught. So we write the x true list and x1 false list. And next is a x produce x1 in brackets, right? So it is the same as a x and a x1. Example, x is a true list and x1 also is a true list. Next is a x produce id1 and rel of id2. If relational operators are used in a Boolean expression, so we create a two lists. First is a x true list and x false list using a make list. Next is a x produce true. If x true, so make x dot true list and make list by using a next instruction. And if x, and next is a x produce false. If x false, it make a x dot false list and make list by using a next instruction. And next is a m produce epsilon. M produce epsilon where Boolean expression evaluating, that time m dot instructions equal to next instruction we produce. So next is some advantages of backpatching. There are key advantages of backpatching. First is handles forward jumps easily, means forward jump target are often not known at the time the jump instruction is generated. Backpatching lets you defer specifying the jump address until it is known. And next is simplifies intermediate code generation. So no need for complex data structures to track unresolved jumps. It just maintain a list of instructions to be patched. And next advantage is reduce compiler complexity. cleanly separates code generation and a control flow resolution and easier to implement in single pass compiler. And next is the efficient management of true false list. In that maintains and updates true list and false lists for boolean expression effectively. Thank you.